Right now, beneath your feet, massive chunks of rock the size of continents are slowly crashing into each other at the speed your fingernails grow. And this invisible battle is deciding where you can live, what you eat, and whether your house will still be standing tomorrow. Welcome to World Explained, where we uncover the hidden forces shaping our daily lives. I'm your guide through the fascinating mechanics of our planet. And today we're diving deep into the most powerful force you've never thought about, tectonic plate. Imagine Earth as a giant cracked egg. The shell, that's our crust, is broken into about 15 major pieces and dozens of smaller ones. These pieces, called tectonic plates, are constantly moving. But here's what's mind-blowing. They're not just sitting on solid rock. They're floating on a layer of molten rock called the mantle, moving at about 2 to 4 centimeters per year. That's roughly the same speed your hair grows. Now, 2 centimeters per year doesn't sound like much, but over millions of years. That's how India crashed into Asia and created the Himalayas. That's how the Atlantic Ocean was born when Europe and America drifted apart. Where these plates meet, that's where the real action happens. There are 3 main ways plates can interact, and each one creates the landscape around us. First, divergent boundaries, where plates move apart. Picture the mid-Atlantic ridge, a massive underwater mountain range splitting the Atlantic Ocean floor. Here, new oceanic crust is being born as magma rises from below. Iceland sits right on top of this ridge, which is why it's one of the most volcanically active places on Earth. Second, convergent boundaries, where plates crash together. When an oceanic plate meets a continental plate, the denser oceanic plate gets pushed under, creating deep ocean trenches and volcanic mountain ranges. The Andes Mountains, that's South America's plate crushing into the Nazca Plate. Third, transform boundaries, where plates slide past each other horizontally. The San Andreas Fault in California is the poster child for this. Los Angeles and San Francisco are literally on different plates, slowly sliding past each other. So why should you care about rocks moving slower than your fingernails grow? Because these movements create the natural disasters that make headlines. Look at this map of global earthquakes over the past decade. Notice something. They almost perfectly outline the tectonic plate boundaries. The ring of fire around the Pacific Ocean, that's where multiple plates meet, creating 90% of the world's earthquakes and 75% of its volcanoes. When plates suddenly slip past each other, that's an earthquake. When molten rock finds a way to the surface at these boundaries, that's a volcano. The 2004 Indian Ocean tsunami that killed over 200,000 people. That was caused by a massive earthquake where the Indo-Australian plate was sliding under the Burma plate. But it's not just disasters. Tectonic activity creates the very ground we build on. The fertile soils around volcanoes support millions of people. Geothermal energy from tectonic activity powers entire countries like Iceland and Kenya. Here's the incredible part. Tectonic plates don't just shape our physical world, they've shaped human civilization itself. Mountain ranges created by colliding plates became natural barriers between cultures. The Himalayas separated Indian and Chinese civilizations for millennia. The Alps influenced the development of distinct European cultures. Plate boundaries are also where we find most of the world's mineral wealth. The copper mines in Chile, the gold deposits in California, the oil reserves in the Middle East, all products of tectonic activity over millions of years. Even our climate is influenced by these moving plates. When India collided with Asia, it didn't just create the Himalayas. It changed global weather patterns, contributing to the ice ages and monsoon systems that billions depend on today. Today, we've learned to live with our restless planet. Seismologists monitor thousands of sensors worldwide, tracking every tremor. Engineers design buildings that can dance with earthquakes rather than break. In Japan, buildings sway on shock absorbers. In San Francisco, new construction must meet strict earthquake codes. We've turned our understanding of tectonic plates into tools for survival. We monitor volcanoes so closely that we can often predict eruptions weeks in advance. The 2010 eruption of Eyjafjallajökull in Iceland disrupted air travel worldwide, but killed no one because we saw it coming. Every day as you walk on solid ground, remember that you're actually riding on a raft of rock, floating on a molten sea, slowly but constantly moving. These tectonic plates built the mountains you see, carved the valleys you live in, and continue to shape the world your children will inherit. The earth beneath your feet isn't as solid as it seems, and that's what makes it so fascinating. Here's my question for you. Have you ever experienced an earthquake or volcanic activity? Share your story in the comments below. If this deep dive into tectonic plates blew your mind, smash that like button. It really helps the channel grow and lets me know you want more content like this. And if you want to explore more hidden forces shaping our world, make sure to subscribe and hit that notification bell so you never miss an episode. Tomorrow we're diving into the ocean currents that control our weather. Trust me, it's going to be just as mind-blowing.